Hey everyone, this is an example video for curve sketching. In this video, I'm going to look at a polynomial. If you're looking for a video that just gives you a really lengthy breakdown of curve sketching, I will drop a link in the comments to an example where I just really work through all the details. I'm going to plow through the details a little bit faster. So just a heads up, if you could maybe like my video or subscribe to my channel, share it with your friends, something like that. That really helps me continue to put free math on the internet. And let's get started. Okay, so I want to sketch this curve, 6 plus 8x squared minus x to the fourth. So first things first, we're going to come up with the domain, the symmetry, and the asymptotes. So this is a polynomial, so the nice thing with polynomials is that the domain of polynomials will just be all real numbers, or if you prefer to state that in interval notation, you can write it like this, although I personally like making the fancy R, it's fun to write. Okay, so now let's do symmetry. So to determine the symmetry, what you're going to want to do is you're going to want to plug in negative x to this function and see what happens when you plug this in. So if I plug all of this in, ultimately what I get is, since these are all even exponents, I just get back to the same thing. So I'm going to have this, which is just f of x itself, which means that we have. And then last but not least, the asymptotes. Well, it's a polynomial, so it's not going to have any asymptotes, so we can just kind of ignore that. So what that means then is if it has no asymptotes, then, and we have all real numbers for the domain, then our critical points, that's going to kind of help us with how we interpret our critical points. And I discuss that more in my other video, again, if you want to check that out. All right, so first things first, we need to determine the first and second derivative. So I would highly recommend that you pause the video, find the first and second derivative, and then hit play when you think you found them. Okay, so I'll find the first and second derivative. So those are nice and straightforward. We just get to use the power rule there, so that's nice. So we're going to use these now for the next parts. Now I need to find the critical points. So I already know my first derivative. Now, because this is a polynomial, there will be no place in this example where this will not exist. So instead I just have to set it equal to 0 and solve. So let me do that. Now notice I factored out negative 4x, that's a GCF, and by doing that, that allowed me to have the higher x term come first, and then that allows me to factor this even further. So in the end I get x equals 0, x equals 2, and x equals negative 2. There are my critical points. Okay, so now let's pivot to talking about intervals of increasing and decreasing, and as a result of that, we're really going to be conducting the first derivative test here, so we'll find our max and mins. So what I would recommend that you do is pause the video here, set up the table that's associated with this, and hit play when you're ready to check your answer. Okay, so I'll get going. Okay, and now I will just show you what the signs in each interval are. So this is something you should already be familiar with. If you're not, I would recommend that you watch one of my videos just on the first derivative test and how to do all of this. That's something that you want to have mastered before you start curve sketching. So now I can see which intervals are increasing and decreasing, so I'll use this information later on. And then I can also see where my potential max and mins are. So negative 2, so notice here I'm going from increasing to decreasing. So this means that we have a max here at negative 2. And then from this interval to this one, I go from decreasing to increasing, so this tells me I have a min here. And then finally here I go from increasing to decreasing, so now I have a max here. So I'll just summarize. Okay, and what you might want to do at this point is plug in negative 2 and 0 all into the function, because you're going to have to plot these points on your graph later. So I'd recommend that maybe you pause the video, go ahead and just figure out what these points are. You're totally going to need this information in a few minutes anyways, so why not get it out of the way? Okay, so up next, now we have to find our concavity and inflection points. So first things first, I'm going to set my second derivative equal to 0, and then I'll go ahead and solve. Okay, so I have here that my potential inflection points are going to be at plus or minus 1.155. So this is just a decimal approximation of this radical here. Okay, so up next, now what I want to do is figure out my concavity. So from here I need to set up my table so that I can investigate my different intervals. So go ahead and pause the video, set up the table, and hit play when you're ready. And I'll just go ahead and start setting it up. And I'm running out of room here, but that'll do. And so again, if you choose a test point in each of these, here is the sign that you will find for f double prime. And again, I'm just not going to show all the details for this. I've talked about this at length in other videos, so I'll drop a link to those in the description. But now I can tell where my inflection points are. So I have an inflection point at negative 1.155 and also at positive 1.55. Okay, great. So let me summarize that. Okay, great. So now I would recommend that you plug negative 1.155 and 1.155 into this function so that you know what coordinate you need to graph on your actual graph. And all that's left now is for us to sketch the curve. So I've already got a curve set up, and I've gone ahead and I've just kind of written out the relevant points that we've found so far. So you usually want to have like a little list ongoing. So let me go ahead and graph those points. And maybe I should also note, let's see, why don't we do this in terms of fives? Okay, and so now I can get started on graphing. So here I've plotted my two maximums, and then there's my minimum. And now I'll plot the inflection points. Okay, so I've got to start here. So now I need to rely on all the other information that I've found in the previous parts of this, right? So here, I know going up to -2, I need to be increasing. So if I come here, here's where -2 is. So to show that this is increasing, I'm actually just going to draw down this way. And after that, I need to be decreasing. Now the other thing to keep in mind is that I'm going to be decreasing all the way to 0. And what I should really see is that from negative infinity to negative 1.55, this should be concave down. So let's work on that part. Now from my graph, I should have that this is a minimum. So I need to turn back up, and then I'll turn back down. So I got all of that off of the tables. So you want to kind of start putting all that information together. And this does make sense now, right? So here we've got concave down. You can see this is a point of inflection, and then we go concave up from here to here, come up to this point, come back down, and now I'm decreasing, and I'm also concave down. So if you were to plug this particular function into desmos.com, I'll write that out for you, desmos.com, you could see just a little sketch of this, and you'll see that we're pretty darn close. So those are the steps for going through with a polynomial. Thanks for watching. And I have a lot more examples, so if you want to see some more, please feel free to watch some others. Thanks for watching.